Hello student, today we are going to study thermal expansion. Thermal expansion, the main reason behind thermal expansion is the asymmetry in potential energy curve. Asymmetry in potential energy curve is mainly responsible for thermal expansion. We will study thermal expansion in three cases: linear expansion, superficial expansion, that is areal expansion, and cubical expansion, that is volume expansion. This is very small chapter but very important chapter from exam point of view. Linear expansion, superficial expansion, and cubical expansion. We will study three expansion coefficient. One is alpha, that is coefficient of linear thermal expansion. Another one is beta, coefficient of superficial expansion. Another one is gamma, coefficient of cubical expansion. Dear student, how alpha is defined? Alpha is defined as change in length per unit change in temperature. Unit is per degree centigrade. How beta is defined? Change in area per unit change in temperature. How gamma is defined? Change in volume per unit change in temperature. And what is relation between alpha, beta and gamma? Alpha is to beta is to gamma. Relation is 1 is to 2 is to 3. This is the relation. Now, dear student, let's see. Variation in density of liquid with the temperature. Density of liquid at theta degree centigrade. Dear student, how do we define density? Density is defined as mass upon volume. Mass remains constant at every temperature, okay? So density at 0 degree centigrade equal to mass at 0 degree centigrade divided by volume of liquid at 0 degree centigrade. And density of liquid at theta degree centigrade equal to mass of liquid at theta degree centigrade divided by volume of liquid at theta degree centigrade. And what can we write for volume of liquid at theta degree centigrade? Volume of liquid at 0 degree centigrade 1 plus gamma L delta theta. What is gamma L? This is coefficient of volume thermal expansion, okay? And dear student, what is m upon v0? This is rho 0, okay? So we can write density at theta degree centigrade equal to density at 0 degree centigrade divided by 1 plus gamma L delta theta. So dear student, if we increase the temperature, then density decreases. Remember, with the increase in temperature, density of liquid decreases, okay? This is very important result. If temperature of liquid increases, then density of liquid decreases, okay? This is the relation. Now I am telling you about the upthrust force. Upthrust force at 0 degree centigrade equal to volume of liquid displaced at 0 degree centigrade into density of liquid at 0 degree centigrade into G. Dear student, upthrust force at theta degree centigrade equal to volume of liquid displaced at theta degree centigrade, density of liquid at theta degree centigrade into G. Okay. So dear student, what is volume of liquid displaced by solid at theta degree centigrade? We can write this is V0 1 plus gamma S delta theta, and density of liquid at theta degree centigrade equal to density of liquid at 0 degree centigrade 1 plus gamma L delta theta into G. So this can be written as U0 into 1 plus gamma S delta theta multiply by 1 minus gamma L delta theta. In brief, we can write U0 1 minus gamma L minus gamma S into delta theta. So dear student, remember this very important result. If gamma L, that is volume expansion coefficient of liquid and volume expansion coefficient of solid, in numerical problem volume expansion coefficient for solid is not given, only alpha is given. So you make gamma solid equal to 3 times alpha. So dear student, if gamma L approximately equal to gamma S, then upthrust force will be almost independent to temperature change, but usually gamma L remains more than gamma S. So with the increase in temperature, upthrust force decreases. With the increase in temperature, this is very important result. With the increase in temperature, since gamma L is more than gamma S, upthrust force decreases. Means what? Body will sink. Body will sink down. Okay. Now, dear students, we will see what is the effect on the time period of a clock. Time of a clock. Okay. When temperature change is there. Loss of time in hot country. Or gain of time in cold country. This is equal to half alpha delta theta is change in temperature and delta T is time interval. Okay. Remember, dear student, in hot country time is lost, in cold country time is gained. Okay. The loss of time or gain of time is independent to the time period. Okay. It depends only on the alpha, temperature change and the time interval. Okay. In hot country time will be lost and in the cold country time will be gained. Okay. Why? Because in case of simple pendulum in hot country, when temperature increases, length of the pendulum will increase, so time period will increase. Okay. If time period will increase, means time will be lost. Okay. So dear student, this is how we will solve the problem. And in case of bimetallic strip, if you want the radius of the arc, we calculate this D is the thickness of the arc. Alpha 2 and alpha 1 are the linear temperature coefficients. The arc will bulge where alpha is more. Okay, this is alpha 2 and this is alpha 1. When alpha 2 is more than alpha 1, it will bulge outside. Okay. Dear student, let's see a question. The length of the steel rod which would have the same difference in length with a copper rod of length 24 centimeter at cold temperature. Because in the question, same difference in length means what? When delta L is same means L1 alpha 1 delta theta equal to L2 alpha 2 delta theta. Since change in temperature is same, so we can solve. What is L1? This is 24. For copper rod, alpha is how much? 18 into 10 power minus 6. And this is L2. And for steel rod, this is 12 into 10 power minus 6. If we try to solve this 10 power minus 6, 10 power minus 6 will get cancelled. From 6, this will be 2 and this is 3. So L2 is what? This is 12. So this is 36 centimeter. This is the answer. Okay. So answer to the given question is option 4. So out of 4 options, the correct answer is option 4. Okay. So whenever change in length remains same, you can directly apply L1 alpha 1 equal to L2 alpha 2. L1 alpha 1 equal to L2 alpha 2. You can use directly this equation. Okay. Understand the meaning of apparent volume expansion coefficient. This is apparent expansion coefficient. This is gamma liquid minus gamma solid. Dear student, if gamma L is greater than gamma S, with the increase in temperature, level of liquid will increase. Okay. If gamma L equal to gamma S, then with the increase in temperature, level of liquid in the container will not change. Okay. This is the apparent expansion coefficient. And relation between alpha, beta, gamma is 1:2:3. Okay. So dear student, in the next lecture, we will be looking very important problems on thermal expansion. Thank you.